Thousands of coconut shells pile up in one of the poorest regions of India. Young engineers are brave enough to use this waste for construction. Why rely on discarded husks? At first glance, it sounds hard to believe. But in reality, they create a truly long-lasting road. The process is only gaining momentum. One can notice how the waste vanishes, changing the environment for the entire community. The secret hidden in this amazing process creates durable infrastructure. Thus, the road is ready for traffic. 19 billion coconuts are harvested every year in the tropical expanse of southern India. This region has been in a tropical climate for many years, where heavy rains are experienced during 2 rainy seasons that are immediately followed by hot weather. This harsh weather cycle causes local roads to quickly collapse under the stress. One can notice how rainstorms cover the base of the land, while the surface of the road is cracked and fractured due to constant expansion and contraction under the heat of the season. But this is just the beginning of the structural problems facing this challenge. Local engineers realized that the famous coconut fiber could serve as a stabilizer. Why did they choose this specific organic material for such a heavy task? It might seem that biological material is too weak for infrastructure. But coconut fiber possesses attractive strength and natural resistance to pollution, making it an ideal material to stabilize the soil and prevent erosion. This process produces a geo-wake shield from coconut fiber, providing a solution for the development of a continuous, low-water, and environmentally friendly road. At first glance, the fabric looks like a simple weave, but in reality, it acts as a complex filtration system. This 100% natural fiber is completely woven from coconut fiber, locking the soil in its place, spreading pressure, and protecting the soil from erosion during rainy seasons. Simultaneously, it remains permeable, allowing water to flow naturally and maintaining the soil structure and environmental balance. It gets more complex further on. And of course, to produce geohexa from coconut fiber, everything starts from the coconut itself. South India is the mother of coconut cities in this country, providing the massive resources required. Various coconut parts are used for various needs. Coconut water is packed to drink, white meat is processed into flour or pressed into coconut oil, and one can notice how even side products are changed into food ingredients. The transformation of coconut fiber into a geoxyl cloth begins here. 10 meters, exactly the height workers climb without a single rope or security equipment. With only a pair of knives in their hands, they ascend the trunk to reach the yield. The danger is constant during the ascent, but this is just the beginning. Why harvest precisely 1 year after the fruit is first formed? To the eye, the timing seems random, but in reality, this duration ensures the coconut husks are ripe enough to be taken for a meal. One can notice how the harvester cuts a piece of the coconut, letting it fall freely to the ground. Every coconut can weigh more than 3 kilograms, creating a heavy impact. It gets more complex further on. At first glance, manual climbing seems like the only option, but in difficult fields or with trees that are too high, workers use long poles. These tools reach up to 10 meters to cut the fruit directly from the ground. Although this keeps farmers safe, the coconut falls strongly. It is visible how it hits open rocks or roots, often breaking the shell. Transition to the next level, the gathered harvest moves to the gathering place on the island for the process of skin removal. 500 to 1,000 pieces per day are peeled by a skilled worker using a sharp wooden stick or logams. Why is this task performed manually? Automation often struggles with the irregular shapes of the fruit. However, a human operator adjusts the force according to the moisture level and size. At first glance, simple, but this method ensures the inner shell remains undamaged. The process is only gaining momentum. One can notice how the thick skin separates from the stem under precise leverage. 35 to 45% of the total weight of the coconut consists of this shredded skin. It is visible how the valuable layer accumulates on the work floor for future use. The stripped coconut moves to the next stage of processing. 2 tons of raw lime fiber pass through the processing lines of the facility every single day. This layer contains valuable organic material that must be extracted with care. Coconut fiber is packed densely into a truck and carried to the nearest processing facility. There, the fibers are thrown into an open area to be stored in rising mounds. One can notice how the raw organic matter accumulates, waiting for the transformation to begin. Why does the drying stage last for 2 to 4 weeks depending on the season? At first glance, such a long pause seems inefficient for industrial production, but natural sunlight reduces the water content from about 65% to about 15% gradually, softening the soap material to make separating the silk fibers easier. A large pile of dried coconut soap is collected by the heavy-duty manufacturer machinery. The load is soaked and moved to a large garbage container to start processing. The collected soap is then thrown into the passenger hopper that directs it to the conveyor system. It seems like a simple transport task, but in reality, the conveyor brings the material to the decorticator unit with a stable and low speed, ensuring a continuous flow for efficient separation. Inside the decorticator, the mechanical action strips the outer layers. During this stage, the rate of discharge reduces moisture from about 15% to below 5% to stabilize the cord. It is visible how the sound combination becomes lighter and cleaner as dust separates from the usable strands. But this is just the beginning. The material is ready to be carried to the support facility where the cord is moved to the part of the head. The head machine works continuously to form a stable and consistent cord band with a capacity of up to 3 tons of cord per day. Here, the cord is released and sorted based on the length, then selected for the next phase. The mechanism weaves the strands tightly and keeps a distance of the net eye, which is consistent to optimize drainage and soil retention. With each pass, the fabric is carefully shaped with a rough, natural texture. Because of this geometry, the material has a high pulling force, so it is suitable for the strengthening of the soil and control of erosion. After the completion of the construction, the roll is checked for uniformity, thickness, and integrity to ensure that it meets the ground-level construction standards. Finally, the fabric is rolled into a large roll, which is ready to be carried out to road projects, locations for stabilization of the rail, or the area of the re-establishment of the land. An average of 100 kilograms of sound compound can produce about 250 to 300 meters of geotextile fabric with a length of 1 meter. The price ranges between $120 and $180 per meter, depending on the thickness and density, marking the end of the production cycle. Massive rolls of GeoXL Coir are loaded into the truck and carried to the construction area. After being located at the precise point, the roll is lowered manually or with a lifting tool, depending on the size and length of the roll. Moving the large continuous roll helps the installation process run smoothly without needing a lot of sewing or ironing. Next, the roll is used to smooth the surface of the ground, removing the streaks, loose material, and uneven places along the track. But this is just the beginning. Why is the surface of the ground smoothed before placement? Ideally, the raw earth would immediately support the material without additional intervention. This preparation creates a solid and even base that ensures that the GeoXL Coir can be placed evenly without any gaps and ensure that it is straight and completely touching the ground. Workers secure the fabric in its place using a pin or pin to prevent the movement during the next construction stage. One can notice how the right alignment and smooth and free surface ensure optimal drainage, soil retention, and evenly distributed load. GeoXL Coir helps stabilize the ground below it, by holding the ground particles in place, especially in heavy rains. The natural comfort structure is stressful and reduces local decline in weak or unstable land. This makes it very suitable for riverside, land-to-land areas, and areas that are prone to erosion. At first glance, spreading a layer of gravel on top seems like a routine covering, but in reality, it helps to secrete the excalc in its place and distribute the load evenly before the layer of soil is added. It gets more complex further on. One can observe that the roadside is made of solid and stable 10 to 15 centimeters thick material to make sure it is strong enough to support the end of the road. This is followed by a layer of soil that creates a uniform base to protect the geotextile from direct pressure. After that, a layer of solid stone is spread on the road to increase the support and repair the drainage. The road was then paved with this smoothness, locking the stones in place and creating a solid foundation ready for the final stage of the asphalt. After a stable base, the steps remain similar to the standard asphalt road. And this is not the limit. It is visible how the asphalt was spread evenly, tightened in several passes, and completed to meet the conditions of smoothness and density. The result is a road that looks like this, changed to a longer road, not much cracks, and with a longer age. Even in harsh weather conditions, the structure remains stable. "6,000 cartons per hour is the staggering capacity reached by the automated coconut water production line. Why does this natural fluid require such high-speed industrial intervention? At first glance, the coconut seems like a self-contained preservation vessel created by nature. But without immediate processing, the water inside would degrade rapidly, losing the nutritional value that makes it a global commodity. While the engineering of road development must withstand harsh climatic conditions, the challenge here shifts to biological preservation. The journey begins inside the processing facility. The coconut enters the automatic system equipped with precision bores. One can notice how the mechanism drills a small, neat hole in the hard shell to extract the liquid inside without contaminating it. After being removed from the nut, the water flows immediately into a cold capacity tank holding up to 1,000 liters. Here, the temperature is lowered to 4 degrees to maintain the nutritional profile. The liquid passes through a filtration system that removes dirt, residue, and excess oil. Finally, the coconut water is filtered for a while longer to eliminate bacteria and cool down again. This ensures the fresh and original value remains intact. But this is just the beginning. The liquid moves to the modern storage line for the final phase. It seems like a simple filling operation, but in reality, the water is sealed into a layer of cardboard that has been filtered before to protect the product from light and air. This helps to extend the storage period significantly. The entire production line is very accurate and efficient, ensuring the water remains fresh and ready to be distributed on a large scale. While coconut water becomes a natural drink, the meat takes a different path to the world of health and beauty. After the hard chocolate stalks are thrown away, workers collect the tender coconut meat. It is pressed carefully to extract precious coconut oil, a genuine gift from a rich nature. This oil nourishes hair, softens skin, and supports health from the inside out. However, the raw material requires thorough purification before extraction can commence. After being cut into small pieces, the coconut meat is moved to an automatic washing system. A place of high-pressure water acts strong enough to completely remove the remaining dirt, sand, and impurities. Some factories even use warm water or a light disinfectant solution for a more effective cleaning process. It gets more complex further on. The cut of the coconut that has been cleaned is put into a grinder with high speed to turn it into a smooth mixture. This mixture is then moved to the machine to press mechanically or cold. One can observe the strong compression place separating the oil from the coconut fiber. This process helps to preserve the natural aroma and ensure a high level of purity, preparing the oil for the next step. After being pressed and strained carefully, the pure coconut oil is moved to the storage area. The automatic filling system measures and releases the oil accurately into every stopper, glass, or plastic bottle. Cleanliness and consistency are paramount. The bottles are then sealed and labeled. The entire process is carried out in a sterile environment to maintain the quality of oil and natural aroma to last longer. The process is only gaining momentum with the production of coconut milk. Grinding and extraction occur immediately after the harvest to preserve maximum freshness. The meat is ground to produce milk and tapioca, rich in soft, smooth nutrition and natural aroma. The material is cooked at a temperature of about 60 to 70 degrees for 30 to 45 minutes. This allows the oil to rise to the surface and removes the bacteria that function as an important step to ensure quality. After the fat is separated, the soft coconut is moved to the packaging line, which is fully automatic. One factory can process up to 2,000 cups of coconut milk per hour. The coconut milk is then put into a high-pressure processing system. This technology uses very high pressure, up to 600 megapascals, to remove bacteria without heat. Thanks to this method, the product retains color and natural nutrition much longer than traditional thermal sterilization. Next, the system arranges the cups neatly into the carton with about 24 pieces in each box. The carton is sealed and labeled with a barcode so that it is easy to scan. This ensures products that leave the factory are distributed to supermarkets and consumer tables around the world. It does not end at this stage. Along with coconut milk, the coconut meat continues to change into a traditional sweetened color. The white coconut meat is sliced thinly with a thickness of about 2 to 3 millimeters. After peeling, the coconut is rinsed with warm water to reduce oil and natural aroma, then drained. The slices are cooked with sugar over medium heat. This cooking process lasts for 45 to 60 minutes so that the sugar can absorb without damaging the coconut shell. Finally, the coconut sweetness is dried at 60 to 70% over the length of the storage period. The material maintains the softness and aroma of the coconut, ready for the next step. Two distinct dates are mechanically stamped onto the packaging to ensure food safety: the production time and the store limit. But this is just the beginning. Why does the processing chain extend to road infrastructure? It seems unlikely for fruit byproducts to bear heavy loads. Yet, geoxyl fiber combinations reinforce the ground, proving their worth in construction. One can notice how the material shifts from heavy industry back to daily life. At first glance, it is just food. But in reality, applications range from health products to beauty lines, proving the zero waste concept. The transformation is now complete.